Hello everyone, welcome to InstantPost Demo Days, the first demo day by InstantPost. I'm really happy to welcome you all over here. As a full disclosure, we would like to disclose that this is a recorded event and the recordings will be made public at a later date after fine-tuning the video. And this event is being live streamed and is available on respective URL that you have already received for yourself. So with that, we will start with the discussion.
So let's begin. Hello everyone, good evening. Thank you for finding the time to join us at InstantPost. So as you all know, this is Yantr. This is our first demo day. And today we'll be talking about the mechanical work that we're doing here and everything related to the mechanical domain of InstantPost. So let me begin. Now, I would like to introduce you to the mechanical team at InstantPost. Myself, Crisanto Abraham. I had been with InstantPost since March. I'm the mechanical design intern here. Tom.
Hello everyone. I am Tom K. Thomas, and I have started working at InstantPost from the month of May. It's been almost 6 months, and I am also studied with a colleague of Chris, and I'm also from Kerala. That's it.
Hey everyone, my name is Devin George. So I have been working at InstantPost since August. So it's been about 3 months, and I'm also a colleague of. So I have studied with Chris and Tom as well.
Now there is one more colleague of ours. Rishikesh Savarkar. He is having his semester exam, so unfortunately he will not be able to join us today. He is also one of the mechanical members at InstantPost and has been with us for the past 2 months now. All right, now let's hear from Akhil. He has an introduction about InstantPost. So over to you, Akhil.
Thank you, Chris. I appreciate it. And let me share my screen and get started. Okay, let me start by welcoming everyone, and thanks for taking our time and attending this event. This is a great opportunity for us to showcase the work that we have been doing for quite some time over here at InstantPost. So let me start with the initial concept at InstantPost, which is all around disrupting the print industry in India, making sure that print industry works as competitive as it can be. And we have a firm belief that the kind of ecosystem we have present around us today is really traditional in nature, and in our opinion, there can be a lot of improvements that can be done. Let me walk you through quickly as an introduction on what we are trying to achieve. So our idea is that everybody should be able to place their orders online via website or our mobile apps, whatever medium they want to use, and then they should be able to print their orders on their own in a self-service model using our printing ATM, just the way you would walk into an ATM to draw cash. Similarly, you can place order online and then walk into our one of our self-service printing ATM, and then over there draw prints, just like the currency notes you would draw out of a regular ATM. Apart from this, we also are working on building a managed print shop, which will host a tabletop print infrastructure. A lot about that will be spoken in this demo day, Yantr. So the mechanical team has been working quite religiously on the products that we are developing over here. So the idea is that instantaneously you should be able to place an order, walk up to our managed print shop or the self-service print kiosk, take that print, and walk away with whatever work for which you had taken that print. So overall, the concept is to make this printing a private affair, which isn't the case in today's date. There are a lot of middlemen involved who would get access to the soft copy that you want to print, and then to be able to do it at a speed which would be as good as almost using a mobile phone and clicking a few buttons to execute the whole order. And then obviously all of this has to come at a competitive price without charging a premium, so that the customers don't feel overburdened in utilizing our services. So these are the three major objectives we are trying to achieve over here. And then let's talk about the market we are targeting. So with each and every product that comes up in today's date, the first thing that everybody wants to know is how big is the impact that they're going to create. So right now we are targeting the education market, and currently in India there are around close to 30 crore students and around 1 crore teachers in the education industry working day in and day out in their respective domains. And interesting part of this education industry is that this industry has been growing by leaps and bounds every year. Mostly the growth numbers are in double digit, and this effectively means that each and every person has been each and every college has been adding more students in every batch. Moreover, there have been more colleges and schools coming up across the country every year. And the best part of the education sector is that at this moment, the public sector expense on the education is around growing around at close to 22% every year, which is a remarkable investment that the government is doing in India. And this brings us to very fast growing industry. And as per our estimates, generally consumers in the education industry spend around 10 rupees per month on their printing expenses. And this gives us roughly a 300 crore market every month to be tapped, which is highly unorganized. And there are no organized players or brands at this moment who are putting a large impact on this industry. So yeah, that's about it. And talking very loosely about the kind of offerings that we have. So we have majorly two verticals where we are concentrating at this moment: the loose prints vertical and the bound prints vertical. The loose print vertical talks about the photos and the documents which are loose in nature. Each and every sheet is independent, while the other one is the bound prints vertical, where we are targeting on printing books and magazines, where a number of sheets stacked together will be bound and curated as a book or an album, whatever may be the customer choice. Then we have an experimental vertical of targeted bound prints, but we are not there yet to be able to launch it in the market. But we are planning to bring in customized, or rather, I should say, personalized magazines that will allow everyone to choose the kind of content they wish to receive, subscribe to the concepts or subjects on which they want to receive content, and each and every magazine would get configured as per their choices, which they can keep reconfiguring every month, and then they try to receive content whatever is of their choice and not what publishers want to push onto them. So this is the overall idea at this moment we have at InstantPost, and we are looking forward to achieve it very soon. So that's my brief introduction, and I would hand it over back to Chris at this moment to explain you more around what is happening on the mechanical side. Thanks a lot, Chris. Over to you.
Thanks a lot, Akhil, for that introduction. Let's move on with the presentation. Now, let's look at the role played by the mechanical team. So we start from the very beginning of designing the product all the way to its fabrication, and it doesn't end there. We try to improve the product and get it fabricated again with more improvements intact. So that includes initially designing, obviously. Then comes the tests that we carry out are CFD, FEA tests, and various other tests as well. And followed by research and experimenting. Then comes the selection of material. Now, selection of material, we take care in selecting the material because there are several objectives that we want to, that we are looking for in the product, which includes lesser weight, less expensive, and many such things that we would be explaining when we describe about each product in detail, followed by fabrication, and then comes the improvement in design. Now, as Akhil had explained, let's look at the mechanical ongoing projects, which include bound print category and loose print category. Now, the machines that we are focusing on in the brown print category are the nozzle, mold structure, binding machine, and trimming machine. These machines will be explained in detail by the concerned member working behind it. So that's the bound print category. Then there's loose prints category. Here we have the kiosk and the CFD simulations. So now let's go to our first machine. That would be the nozzle, and Tom would be the best person to talk about that. So let's hear from you, Tom.
Thanks, Chris. Welcome everyone. So this is a nozzle, and this is the first project that I have started working once I joined InstantPost. So as you can see here, this slide describes the basic components that contribute to the nozzle. So there is an adapter, there are two sliding plates, two guides, two rings, and an inlet board and a cover. So let me just first explain to you why we are actually using a component like this. So as you can see on the next slide, this is the standard glue gun that we are using. So as you can see here, there's only a single nozzle that comes along with it, and the nozzle cannot be, used to have a different width size. So that's where our uh, product comes into picture. So these guides, as you can see here, can move on both sides, and these rings actually control the movement of these guides, and which can be easily done with the help of your fingertips. So and this inlet port, as you can see here, is connected to the inlet of the glue gun, and that's how this whole mechanism actually works. So now I'll show you just an explorer view of the nozzle. So yeah, now let's go on to the next slide. That's the scope for improvement. So as you can see here, aligned movement of sliding plates without much effort from the user. From the slide, you can see the user needs to use both two fingers to move the slides on both directions, so that you can move the guides along with that. So reducing that would be our next objective, and selection of a better material that suits the characteristics of this device. So why we need to select a better material is a choice, because we need the glue to be actually in a molten state, and once the molten glue actually enters into the adapter, the adapter is actually metallic, probably made with aluminum, and it dissipates a lot of heat. So in order to reduce that, we would go forward with a better selection of the material. So yeah, so that's it about the nozzle. So now over to you, Chris.
Thank you, Tom. Now let's go back. Let's go to the next bound print product, which is the mold structure. So we know that while using a glue gun, a lot of glue would be gone to waste, and we don't want that, because in the binding process, you utilize a lot of glue, and the glue gun will be working almost all the time. So to avoid that wastage of glue, we are introducing the mold structure. Here, uh, the solid glue, the waste glue, could just be put into the funnel, which would have a heating coil wound around it, which is in turn connected to a thermostat, which would heat up the heating coil. That melts the glue. The molten glue will then fall into the mold you see there, and which takes the shape of the glue stick that is available in the market. So we are recycling almost all the glue that is gone to waste. Now let me show you each piece of this mold structure that would be there. That is the dismantled view, and the assembled. Yeah, please watch the video. So here, that's the funnel. the funnel can be removed like that. So after the glue is ready, I mean it's solid, the funnel will be removed like that. Then one piece of the mold would be removed. Yes, this way the solid glue, the stick inside, can be extracted. So that's about the mold structure. And then comes the scope of improvement. Here we are also looking into automation of use. So initially it is manual. We will be removing the mold, the funnel, excuse me, the funnel and one side of the mold manually, and then extracting the glue out. So we want to automate that, as well as multiple mold facility also. Here we are just recycling one candlestick at a time. We would like to uh, recycle multiple candlesticks. So that is about the mold structure. Now let's go to the binding machine. So this binding machine is a manual machine which uh, which helps in book binding. So let's watch the video first. Right, there you go. So this yellow portion, that's the book, and it's going to be clamped to the to the all right. So let's come back to this video. So yeah, that yellow portion is going to be the book. It's going to be clamped to the back plate using this slab there, and these are going to be the pulleys that you can see, one over there and one at the bottom, which is going to be connected by a belt. It's a timer belt, and the white slab there you see, that is the linear motion block. Now, after watching the video, you will know the purpose of each and every of these components that you see here. So the book is going to be pulled up, and please note that this is the spine of the book, which needs to be glued. Now, initially when the book is placed, it's going to look like this along with the cover. The cover is going to come out of this slab there, which is helping the book to be clamped to the back plate. It's going to be like this initially, and as the book is being rotated, it's going to go up to 185 degrees, and at this position it's going to rest at this back slab, which allows the book to rest in this position stationarily without falling back. Now here uh, the cover page is going to look like this, and the glue is going to be applied over there. Watching the rest of the video, after the glue has been applied, it's going to come back down. Now, along with this rotation, you must have also noticed that the linear motion block moves back as well, which is with the help of this mechanism. This mechanism is called the Whitworth Pick Return mechanism, and if you watch carefully, you can see how the linear motion block goes back, utilizing the slotted link and a link which connects this slotted link to the linear motion block. Now, the purpose of the linear motion block is that after the application of the glue, when the book comes back to its initial position, the glue makes the spine. It doesn't give that spine the shape it wants, the finished shape. So the linear motion block comes into use here, where it sandwiches the spine between the stationary block you see at the back and between the linear motion block, which distributes the glue uniformly throughout the spine and gives that exact rectangular shape for the spine. So that is the whole working of the binding machine. And this machine would be of great use for in campuses, in college campuses, because as we all know, students would repeatedly require this binding process for their projects or whatnot, and they would need it quickly as well, urgently. So in such a case, uh, in a conventional method is that as soon as an order is given for bookbinding, a vendor, a average vendor, he would take that order, I mean the pages along with the cover page, to a bigger stationery shop which has a bookbinding machine. Now there are bookbinding machines in the market, but they are not manual and they cost a lot, which is why only these big, large scale stationery shops will be able to afford that. Now, after they take it there, it's going to take a few more days for the book to be bound. The vendor will then bring it back to its shop and deliver it to the customer, which takes at least 2 days. Now, with this machine on his tabletop, he'll easily be able to bind the book in front of the customer and give it to him right away. So uh, now let's look at the scope of improvement. Now, weight reduction is our main focus when it comes to this machine. Weight reduction, lesser parts to assemble, and assembly is also going to be much more simpler. Then we're also looking into semi-automation. Now, semi-automation means that over here we see that each work, application of the glue, rotation of the book, bringing it back down, everything is done manually. Now, semi-automating it would mean the glue would be applied by the run of the glue gun. So that run is going to be automated. That is our semi-automation we have in mind. Then complete automation would be just placing the book along with the cover, placing the pages along with the cover page, and we will only see the book after it's been completely bounded. So that is what we mean by complete automation, and that is another scope for improvement when it comes to the binding machine. Now, the next machine would be the trimming machine, and let's go back to Tom and hear from him.
Thanks, Chris. So yeah, as Chris said earlier, once the binding of the book is done, the book needs to be properly cut into the specific size that the user requires. So this is where the finishing machine actually comes into play. So the basic function of the finishing machine is to cut all three sides of a specific book size in a single go. So as you can see here, the machine actually consists of a lot of complex parts. So let me just show you the video and explain all the parts one by one. So as you can see here, it is the complete machine. So the blue ones are the supporting rods. The green parts on either sides are the block bearings, and there's also another bearing at the center. And this yellow part is called the press head. And the function of this press head is actually to hold this lead screw. And this lead screw is actually from where we would apply the force, so that this top plate, as you can see here, moves up and down. And this brown portion is actually the book, and this red portion behind the book would be the a part that holds the book in place. And as you can see, the last part is the base of the whole machine. So let me just show you how it basically works. So this is how actually works. So once the spindle is turned, the top plate moves down along with the bearings. The bearings are attached to the top plate through an L-shaped plate, and this top plate is further connected to a blade supports which holds the three blades. The silver colored objects are the blades, as you can see in the video. Then once it moves down, it cuts the book in all the three shapes. I mean, all the three sides, and the spring here is provided so that once the cutting is done, the spring pushes the top plate back to its initial position without any much effort from the user. I mean, from the user. So that's a basic working regarding the finishing machine. Now let's just go into some simulations that I have done. So before I move into that, I would like you to look at two parts: the top plate and the blade support. So this top plate and blade support are two major components in this machine, which comes under a lot of stress and buckling. So what this stress actually means is that once this blade comes in contact with the book, the blade is under a lot of pressure. Since it's a 30 book, the blade would be under a lot of pressure, and this stress would be further uh, given to the top plate. So I have done stress analysis on these two parts. So why is the need for simulation study? To calculate the optimum size and shape of the machine parts, then top plate receive the most of the stress, and the blade support have the most chance for buckling. So buckling actually means is like to bend under stress. So so first is the stress analysis on the top plate. So this one is an analysis that I had done for the top plate. So as you can see here, it shows the deflection at the center of the plate. Uh, as you can see, as time passes, the deflection increases, and it reaches to a maximum after some time, about 2.242 after some time. So this simulation actually indicates that such a plate with a thickness of about 1.5 is not a suitable option for the machine. So that's regarding the stress analysis for the top plate. Now comes the buckling analysis on the blade support. So this is actually the blade supports, and in these indentations we actually place the blades and screw them. So a force was given on the blade supports, and let's see how it reacts to the given force. The current deflection for the blade support is 0.2 and as time passes, it further goes to a maximum of 1 And that's it regarding the simulation study. Now let's go on to the scope for improvement. So the weight of the machine is actually a major factor that needs to be considered, since all the materials are metals. So this metal contributes to a large weight for the machine, and which is not economical as well as not a user-friendly one. So reducing the weight with different modifications in designs would be an objective, and the development of a single machine to accommodate for different book sizes. As I have said here, this machine actually is for a specific book size, but in the future we are looking forward to accommodate different book sizes for a single machine itself. Then the last point would be to move to a semi-automatic design. That is, in the semi-automatic version, I would be looking forward to give the force in using a motor. Like in this case, we would actually need to manually rotate the spindle to give the force on the book. But in future words, we would probably use a motor and a similar mechanism to give force. And when we move further forward to an automatic paper cutting machine, we would be further uh, automating the whole structure. Like just place the book and press the button, and we will get a finished book afterwards. So that's it regarding the finishing machine that I've been working on. So now I'll give this to Chris.
Thank you, Tom. Now that's it about the bound print machines. Now comes the loose print category. So here, there's just one print happening at a time. That would be the kiosk. Now, kiosk is a joint venture by the mechanical team and the embedded team. Here, uh, Tom would be the best person to talk about this. So the kiosk, and followed by the CFD simulations. CFD simulations are focused on the cooling system that we have inside the kiosk. As it focuses on the cooling system as of now, and because there are many components inside the kiosk which would heat up, and that heat has to be removed as soon as possible and most efficiently. So CFD simulations are taken care of by Jebin. Kiosk, we can hear about the kiosk from Tom. So Tom, back to you.
Thanks again, Chris. Yeah, so let me just explain to you what are the basic components of the kiosk. So as you move to the next slide, as you can see, there are a lot of components that comes in front of the kiosk as well as inside the kiosk. Let me just explain to you what are the basic components that comes in front of the kiosk. As you can see, there are first category are the adapters, which goes on like keypad, LCD screen, RFID scanner, fingerprint sensors, coin acceptors, and memory card reader. And the components that comes inside the kiosk, like a printer casing, a UPS, a cooling system, and an SLPs. As you can see in the figure you can see is the door of the kiosk, the front of the kiosk actually, and at the top left you can see an LCD screen, and afterwards a keypad. Then there's a memory card reader at the right and a coin acceptor at the bottom right, and a printer casing just left to that. Then a fingerprint sensor on top of it, and an RFID scanner on left of it. So let me just first explain to you why we are actually creating such a system. So this system actually comes under the loose print category. So how the system actually works is like the user actually uploads his documents in a PDF format into the company's website, and he further receives a verification code, and he comes into in front of the kiosk, and he enters the verification codes through to the kiosk, and he would receive the bound prints from the kiosk through the printer casing. So that's a basic working for in case of the kiosk. And let me just explain to you why are the other components there. So that's a printer. As you can see, the printer we are using to get the prints out, and the printer casing is to support the printer to get the the prints out. And another objective of the printer casing is to make sure that the paper coming out from the printer does not stack. And there's a UPS which comes under the power supply system, and there's a cooling system that Chris was explaining earlier, which would be used to cool all the components inside the kiosk. And last, it would be the SMPS, which would be further connected to the electronical systems of the kiosk. So this is for the front side that the kiosk actually looks like. So the kiosk door actually consists of a metal frame, as you can see here at the side, and at the center you can see a glass frame, which is actually acrylic, and it's actually acrylic, and the acrylic part is given extrusion such that all these adapters are incorporated in the acrylic cover. And the acrylic also has some LED lighting system. This is actually a representation of the system that we are planning to design. And this is actually the system that we are working on. So that's it about the kiosk front. So now let me just ask Jebin to share the rest of it.
Thanks, Tom. So once again, welcome everyone. So today I'll be talking about the simulations that we are conducting right now. So the reason why we are doing this is, as you have seen, we have the kiosk, and it has the parts, different electrical parts that constantly heat up. And since it's a very closed environment, this will drastically affect the performance of the kiosk, as well as it will reduce the life expectancy. And also we do not need constant maintenance for the kiosk that we are building. So we have created a cooling system which is based on a Peltier setup. So why this Peltier setup is created is that it is very durable, and it needs very less maintenance, and it is very cheap to afford. So also we won't need to maintain it, repair it constantly. So also, the kiosk cooling system is placed behind the system that Tom had shown above the printer. So so why we need the simulation part in this cooling system is that we had already developed the prototype for the cooling system, but it was having the errors that comes with the physical model. It has different problems like outside air interacting with it, and also the results that were obtained will vary and based on the sensors and different parameters that have that can affect such a prototype. So in order to combat this, we were using a CFD. We started using a CFD simulation. So CFD simulation is stands for a computational fluid dynamics. It is actually a branch of fluid mechanics, which means it studies the interaction between the fluids, that is gas and liquid, with its environment and its interaction with the surroundings. And so let's move on to CFD. So CFD is a very modern method of simulation and problem solving. It is a branch of fluid mechanics that combines modern day computing power with numerical analysis and data structure to predict how the fluid flow would interact with the environment. So numerical analysis basically means that it uses a set of equations and basic equations that are governed by the physical laws. So these equations will predict how the fluid will interact and how it will communicate with other materials that it is in contact with. For example, if we consider an IC chip inside the laptop right now, so if you visualize it, you can see that there's a heat transfer between the chip and the atmosphere. So we can use the CFD software to visualize how it will interact, the air, inside air will interact with this chip, and what kind of temperature and velocity should the inlet fan should have in order to cool that chip. So, and also it can be seen all around us. So the ceiling fan that we use and every home appliances we use are all based on the designs that have multiple prototypes based on these CFD simulations. So, every simulation has three major parts, that is pre-processing, solving, and post-processing. So pre-processing means the creation of a geometry that needs to be solved. So basically, if we have the problem statement that is, let's say, a heat transfer, and we want to create the geometry that we need and to solve that. So in order to solve that, we can't solve the entire geometry at once. In order to simplify it, we need to divide the geometry into a number of small fragments. So this is done by a process called meshing. So these meshing helps in dividing the geometry and also dividing the equations that govern this geometry, so that we can get a result with very less error. So also you may be familiar with meshing in a 3D printer. So let's move on to solving. So solving, as I said earlier, the geometry is divided into tiny fragments, and each of these fragments are solved by particular basic equations that govern the laws of physics. And also, there are different types of equations that govern different kinds of simulations, and based on the conditions and based on the conditions that we are involved. Also, next is the post-processing. So post-processing means the analysis and viewing the results. So the results can be obtained and be viewed in different software, and mechanical engineer can visualize these results and understand where the flaws are with the current design and improve upon it. So he can create a newer version, which is a better version from it. So let me move on to the advantages of CFD. So traditional methods of designing are based on build and test method, including the use of wind tunnels and other machines. So these machines are not accessible to everyone, and also the investment that goes into such an experiment would be very huge. So for a startup like InstantPost, it would be not feasible to use such a experiment and such experiments and such machines. So in order to combat that, a lot of companies have moved to a cheaper method, that is the use of this CFD technology with the help of high power computers, which is very cost effective and does not limit the capabilities. So also it is very flexible and can be used in different problems that and can be varied according to the needs that we have. Also, now their design can be easily based on their simulation and make improvements within very less time and limited amount of resources. It also reduces the limit of physical size. For example, if we can even simulate the movement of a life-size ship through the waves. So something that is impossible in the other methods like a tunnel system or other machines that we already have. So another advantage is the simulation of hazardous events such as explosion or how fire would travel or the reactions of a poisonous gas, which are not possible to be simulated or be deeply studied using the normal methods that we have. Also, a lot of researches and theses are created based on these CFD simulations. So they are the basis, and they cite these CFD simulations. So it gives us a better understanding of the physics of day-to-day things, as well as a lot of researchers use this kind of data. Also, let's move on to the applications of CFD. So CFD has a wide range of applications from, let's say, aerospace. It helps, it defines how the wings and the entire plane will move without any drag and having the maximum lift that the plane can have. Also, as you can see in the figure here, this is a Formula One car. So in the automotive industry, so this is a pressure velocity simulation of a car. So this defines how and where the pressure is concentrated on the machine and also how the wind will blow against these machines. So this would usually require a wind tunnel, but with the CFD, you can accurately move to each and every single piece of the machine of the car and accurately give a result. And based on that, we can move on with a better design. So next, electronics, like I said, in the IC chips and a lot of instruments within the electronics, we use CFD simulations to show that how it can be cooled and how effective it is. And next is hydraulics. So the pumps and all the compressors, such kind of devices that blow out air or any other fluid are all simulated in such a way that there is no backflow of the air or there's no blockage of such a system. And also in constructions, if we consider the construction of a dam, it is a very important simulation part of the CFD, and so how the what kind of force and at what extent the force is exerted on the dam by the fluid, and such also how wind will affect the a tall high-rise building. So also in medical industry, the flow, we can even simulate the flow of blood through heart, arteries and vein through CFD simulation. And also it helps in creating other small devices and how it will, very small device will travel through blood and such kind of analysis. And even sports on how to create a better tracksuit and how a swimmer passes through water at very low, small time and how he can improve upon it. So every walk of life has CFDs linked to it and such kind of simulations. So next, let's move on to OpenFOAM. So OpenFOAM is the CFD software that we have been using. It is an open source CFD software that is based on the C++, and also it is a free software, and it has a creation of, so how it works is it has multiple number of solvers. So these solvers cater to the applications that a wide variety of people may have. So people can use it according to the solvers and that they want. It is very highly flexible and robust, and you can even create your own solvers based on the CFD initial, OpenFOAM initial standard solvers. So it can be created and customized, and it is tailored to the needs of the user. And also, it gives results that is very comparable and very close to the simulation results and the real life physical models that are created. So, its capabilities vary from simple flow, heat transfer, acoustics, electromagnetics, and much more. It can even do financial simulations. So it is not just limited to engineering. It's not even limited to mechanical engineering. It has parts in electrical, civil, and even sound engineering. Also, a large number of people, especially in universities, the students, professors, use it for their theses and research because of its open source and reliable nature. It is used widely by people across the world, and also even multinational companies use CFT open form software. Also, in our case, in InstantPost, for InstantPost, our application is in developing the cooling system as well as creating. So we work in the heat transfer part of OpenFOAM, and it is we have been working with the cooling system on with OpenFOAM. So it is giving us results that have been matched with the prototype that we already created. So we also have two other softwares that we need for completing the open form simulations. That is, so initially I said that every simulation has three parts: meshing, geometry creation, and finally the viewing the result. So these two, Salom and Paraview, are two of other open source softwares that have been used along with Open Form. So Salom basically works on the geometry creation as well as the meshing part of the simulation, and Paraview is a software that works on the result part, viewing the result as well as analyzing it. So all these three softwares work in tandem with each other. And next, let's move on to a simulation that we had already done. So this is a basic cooling system setup. So this is the cool side of the system, which means that this is the tunnel that will be pointed, will be inside the machine and will be cooling the system. So as you can see, this is a tunnel, and inside these are heat sinks. Heat sink is just a metal aluminum part that will conduct the cold temperature to the air. And here we will have a Peltier plate. So what the Peltier plate does is it has when opposite polarities are given to the Peltier plate, one side will heat up and the other side will get cold. So the cold side will be connected to the heatsink, and air from the inlet will be passing through the tunnel through multiple heat sinks, and at the output it will give us temperature of a reduced temperature from the air. So that's how we are going to, and this air is going to circulate within the kiosk, and this will give us a cooling cycle, and this will reduce the temperature within the system, and it has to travel through the entire system and along with the electronic parts as well. So this is a system that we have been working on. So now let's move on to the simulation part of it. So this is the simulated part where this is the inlet and this is the exit. So as you can see, the hot air, which is in this simulation at around 300 Kelvin, which is 27 degrees Celsius, is passing through the tunnel at a temperature of at a velocity of 1 meter per second. And as it passes through the successive heat sinks, which are at a temperature of 0 degrees Celsius, you can see that the temperature, according to the temperature scale here, the temperature is decreasing from 300 to a temperature of around 280 Kelvin. So as it passes through successive heat sinks, the temperature at the center is much cooler than the one at the side. And after further passing, it cools down and cools down until it reaches a temperature of around 28 to 80 Kelvin, while at the sides it's still at around 290 Kelvin. So what this teaches us is that we need to increase the number of fins, and so fins of the heatsink, so that there is cooling even on the side. So these kind of improvements are what we want in the system. So this will allow us to create the next heatsink, which is has more number of pins and has equal distribution of air within along it, so that we can have reduced temperature. So from 300 Kelvin, we have reduced it in the simulation to around 280 to 285. So if we increase the number of heat sink, we can reduce it further. So this is the kind of analysis and the results that we obtain from such simulations. So next is the automation part. Now automation is a very successful part of a very InstantPost should be proud about it. So so automation of OpenFOAM has helped us. It is not actually done by many of is not it is a very unique feature to us. So automation is the running of the simulation on the server from the meshing part to the end. So it completely runs on the server without the need for any human supervision. So usually what we have to do is at each level we have to uh, check the simulation and see if there is an error, or we have to do the next step. But according to the automation that we have done, we just have to upload the files and it will automatically do the simulation and give us the results. And it provides a common platform for anybody to view the results. So it's not just limited to a person. Usually it will be needed, the entire simulation folder will be needed to be shared from one person to another. So instead of this, we have created a system in which anybody can view the results. So what next? So right now we are basically working on the tunnel, the cooling system and cooling system tunnel. So just like the geometry that you have seen earlier. So right now, what we want to do next is the simulation of the entire atmosphere inside the kiosk, how the each metal part will heat up, and for how long it will stay like that, and such kind of predictions. And we have to do such kind of things so that we can predict how and what temperature and velocity should the inlet air have, so that the cooling can be effective. Also, another part is increasing the efficiency of the cooling system that we already have. So these are the kind of challenges, and we are working on right now. So that's it from my part. Thank you. Now over to you, Chris.
Thanks a lot, Jibin. Now that brings us to the end of this presentation. Last but not least, we have the Q&A session. I'm sure that you'll all have some sort of doubts for us. Please go ahead. Please feel free.
Hi. So I was wondering, for the bound prints, what are the adjustments that will need to be made for different types of books, like for thin or thick books, or with different sizes of books?
Okay, that's a good question. Let me come to that. So if you look at this video over here, you can see that the book has been clamped to the back plate by using this clamping tool. So that clamping tool helps the book. It can be tightened with nuts over there. You can see two screws coming out on either end. So depending on the thickness of the book, the clamp can be loosened and then put it back in and tightened along with the nuts. Now same goes for the linear motion block. Now this block, the linear motion block, also can be fixed to this rail. Now that rail is not stationary, as you can see. The rail will move back and forth along with the linear motion block. The rail is what carries the linear motion block. So, for a thicker book, the linear motion block can be moved back a bit. The book can be placed over there. Initially, the pages along with the cover page is placed initially, clamped. Then the linear motion block is adjusted at the spine, brought as close as possible, as tight as possible to the spine, and then screwed on either end, which tightens it to the rail system, to the rails over there, which then carries the block back and forth according to the rotation of the back plate. Uh, so yeah, that, and then it goes to 185 degrees and does the bind, comes back down, and that is where the book is being sandwiched between the stationary yellow block behind and the linear motion block. So yeah, so does that answer your question?
Yeah, it does. Thank you.
Thank you very much.
Another question I had was, are there any limitations you can foresee for these machines?
Limitations for this machine. So this is our first prototype. So the first prototype will definitely have limitations. It has to have limitations, only then we'll come up with improvements. So the limitation we have here is that um, the pages and the cover page has to be properly aligned. I mean, the cover page. So you saw the trimming machine that Tom had explained. So the whole purpose of the trimming machine is that the edges have to be cut so that the book looks neat. Now, what if the pages are not properly aligned with the cover page? While trimming, uh, top the top portion of the, let's take an example. If it's not properly aligned, say the top portion of the pages are going to be cut in the trimming process along with the cover page, and the bottom, it's only the cover page that's going to be cut if the pages and the cover is not properly kept aligned. So that is one challenge that we are dealing with now. That is one drawback we have here. Then another drawback would be fabricating these components in metal. That adds to the weight drastically. And initially, in the first prototype, we have quite a lot of loose pieces which need to be assembled. So the assembling of these pieces need only one person, but will take quite a lot of time. That is why we are thinking of incorporating plastics into this, which can be which can be 3D printed as a whole. I mean, instead of like, it's just like welding two pieces in metal. Plastics, we could just 3D print that, and yeah, thereby reducing the amount of assembled pieces there. So these are a few drawbacks that we are dealing with now.
Okay, thank you for clarifying my doubts.
Thank you very much. So are there any more doubts that needs attention? Please feel free.
Hey Chris.
Hello.
Yeah. So I was asking like how your kiosk is different from others that are already present in the market.
All right, the kiosk. I think Tom would be the best person to answer that. Tom.
Okay. Uh, so, Priya, the kiosk actually comes with the, as I have explained earlier, the kiosk actually comes with a lot of adapters, which are, which you cannot actually find with the uh, kiosks that are in the market actually. But I believe that there's actually not such of a technology that it's being used in the market like the kiosk that we are building right now. Like obviously online printing is has been in the market, but uh, with the such a kiosk system is in the market, I believe. So does that answer your question, Priya?
Oh, okay. And one more thing, you guys are talking about the bindings. So do you provide hard binding also?
Priya, could you briefly explain what you meant hard binding?
Like in colleges, we just want to print the reports. So there we need the hard binding. So your kiosk is also providing these hard bindings.
Hard bindings meaning the cover being hard.
Yeah, the cover being
Okay.
hard, and also a cover means printed with the golden color.
Okay. So here with the binding process, the color of the cover that doesn't matter. The color is totally dependent on the printer and the way we print the cover page. But hard bindings here are a problem because in this video, excuse me, not this video, this picture explains exactly why that's a problem, because you can see that after the book has been tilted to 185 degrees, the cover page has to be bent. It will go back. It has to go back so that the glue can be applied there using the nozzle. So for that cover page to bend like this, it has to be flexible enough. Now the hard copies, hard covers will not allow for this. It's going to end, zoom in, yeah. So it's going to come right up till there, which will not allow us to apply glue on the spine. So as of now, hard copies are a problem to us, and yes, we are working on it as well. That is another problem that we are facing right now.
Okay, thanks, Chris.
Thank you, Priya.
Hey Chris, so in this bookbinding machine, there's no form of stitching or stapling that's involved, if I'm right?
No, nothing at all.
So how reliable and strong will be your bound books?
So yeah, the strength of a book totally depends on the glue that we use and the time we give for the glue to bind properly the pages and the cover page. Now, here care has to be taken while stacking the pages properly at the bottom along with the cover page, which actually gives a plain surface at the spine. Now, when the book is at this position, tilted at 185 degrees, we want the spine of the book to be perfectly straight so that and none of the pages going up or down, so that the glue touches each and every page and fixes it firmly with the cover. So it is quite reliable as long as not much force is given on the spine. But like any other glue bound book using any other machine, the strength of the bind is totally the same.
Won't the glue, if excessive glue is applied, won't it damage the papers? Because only being used by only the glue is the entity that's holding all the pages. So is there a chance of dripping through the papers and damaging it because you're not using a stitching mechanism or something like that?
It's not going to go through the paper because through the pages. You mean through each of these pages? What if the glue drips? Is that your question?
Right, not like exactly through the pages. Like since the glue will be wet, is there a chance that the paper becomes soggy and the entire document set is damaged? Is there a chance that can happen?
Okay, so we have done trial runs using the nozzle. So we have our first prototype of the nozzle ready, and we have done trial runs. There are no such cases of the pages getting damaged or getting soggy because the nozzle allows only so much glue to be deposited on the spine, because we are adjusting the width of the nozzle along according to the thickness of the book, and there is barely enough gap for like a thin film of glue to pass through the nozzle and fall on the spine. And this glue it solidifies quite fast as well. So there is no such case where the pages get soggy or damaged. And the linear motion block makes sure that the glue is deposited evenly so that none of the pages or no particular portion of the spine gets more glue and which leads to damage over there. Yeah, so the linear motion block makes sure of that.
All right, thanks, Chris.
Thank you, Ayush.
And just to interrupt you, Chris, I would like to add a few more details on this gluing mechanism. So the question put forward rightly lays emphasis on the ability of the glue to impact the printed documents. So in this case, the glue that we are using is hot melt glue, which are thermoplastics that are melted at a desired temperature, liquefying them to be applied on the spine of the glue. So there is no water in this whole glue application mechanism that can make the pages soggy at all at any point of time. So this is the benefit that we get out of thermoplastic glues, where we bring them to a temperature where they will liquefy, and then we apply them in the desired shape, desired place we want, and then we use the linear motion block to give it the desired shape before it starts solidifying. And when it solidifies, it basically chemically bonds with the cover paper as well as the printed paper inside that we are actually binding as a book. So at that moment, it forms a chemical bond with both the substrates that it is binding together, and that's how we do not run into a situation where the glue can negatively impact the quality of the print or the paper. And to substantiate this, we have shown these books bound using the wooden prototype that we have built earlier. We've shown them to the traditional printers who do book printing, and we asked them if they find this quality of binding to be appropriate for their use. And they did try all kind of possible test that would allow them to understand how good the quality of the glue is, or how good the whole binding process is in general. And they could not find any visible or immediate flaw in the binding. Plus, they did not even realize that this book has not been bound using traditional methods, and it has been bound using one of our experimental binding machines. So this is what we have been able to achieve so far on our binding machines. Going forward, we will definitely keep on improving that further.
Another question, a quick question. Will this binding machine have any limitation on the minimum or the maximum number of papers, or is it flexible enough?
So the thing is, I would let that to be answered by Chris. Chris, can you answer that question?
Yeah, sure. So that does not pose a problem here because this binding machine is capable of binding books in the range of 5 millimeters to 40 millimeters, the thickness of 5 to 40 millimeters. And the nozzle also is equipped so that it can be adjusted to accommodate that kind of thickness. So does that answer your question, Aish?
Yeah, so while explaining the machine, you gave an example of where you could put it in colleges, if I'm not wrong.
Mm-hmm.
So, but in colleges, other than the final year project, all the mini projects and your semester projects have pages in the report consisting of maximum, I think, around 15 pages. That's way lesser than 5 mm, right? So, how will you be tackling that issue?
So that is not going to pose much of a problem because even if it's 5 pages, like 15 pages, as long as the nozzle is used with care, only a thin film of glue is going to be deposited. So for a thicker book, we'll have to run the nozzle at least 2 times so that enough glue is deposited and all the pages come in contact with the glue. In case of a much thinner book, much lesser than 5 mm, the nozzle only has to be run just once along the spine, and yeah, the rest of the work will be done by the linear motion block, and also the operator handling the binding machine and the nozzle also will be an experienced personnel who will definitely have that kind of an experience with a wide range of books with varying thicknesses.
Chris, why don't we also ask Tom to answer this particular part where width of the book spine can be, I mean, in terms of the nozzle, how it functions, adjusting the width.
Yes, sure. Tom, go ahead.
Yeah. Uh, okay, let me just share and show you. As you can see here, these two parts called guides are actually controlled by these rings, which are further connected to the sliding plate. So, if you have a 5 mm thick book size, then we could use these rings to control the thickness of the, I mean, the width of the opening to be about 5 and we can place this easily over the spine of the book, and we can easily move this along the spine of the book, so that only a a small thin curtain of glue comes over that 5 thick section, and no further glue gets wasted or deposited over the spine. And in a way we can ensure that no glue leaks out of the page once it's covered, or something like that.
So let me add to that answer for the question. So Ayush, the question that you asked, that the books that are going to be much thinner than 5 mm. So right now, this particular binding machine won't be able to support that thin bind, and 5 mm has to be the minimum thickness of the bind to be able to be used on this particular book, big book binding machine. So this is the range that we are building it for, but we can always modify this machine, and we can always keep on iterating to accommodate all the actual requirements. Since we are at the beginning stages, where we first need to assert the fact that machines can work durably and produce consistent results over a long period of time while they are being used. So these are the things that are an immediate, I would say, immediate attempt that we have at this moment in our mind. And as we move forward, we will definitely work on all the actual requirements that the college students may have. So right now, particularly with the books, our main interest area is to serve the faculties. So a number of faculties have to get their books published, and more or less in many cases what happens is they get only a few copies printed, for which they have to run a lot around. And in such a scenario, we want to provide them an on-campus solution where they can print a few copies very easily using one of our binding machine or the tabletop infrastructure that mechanical team spoke about. So that's the immediate target that we have in mind. Obviously, whenever there are people who are printing in bulk and they have around 50 sheets or a little more than that, they would become immediately eligible for that binding. So this is not to say that we are only trying to serve the faculties, but that's our immediate aim, to first build a robust binding machine and then cater for all the edge cases that we may have. Does that answer your question, Ayush?
Yes, Akhil. Thank you.
Okay, guys, if there are no more questions, we shall end this presentation here. It was a big pleasure having this presentation before you. You guys take care and have a nice Saturday weekend.